Hello everyone. We promised to look into the IP addressing structure systems, and this is the video to explain that. So we'll see how we can, how far we can go with these. We just want to look at the basics, the fundamentals, the basics, the fundamentals of IP addressing system structures, so that when you start looking into this into the course, all this will become way easier, especially for the system admins, people that they do not really have a networking background. This will come in handy. So IPv4 addressing is a 32-bit system of address. To make reading this 32-bit system that we talked about, to make it simple, is divided into 4 portions. Each portion is referred to as octet. So you see something like, if we look at this 0, 1, 2, 3, 4, 5, 6, 7, 8, then you have a dot here, then I put a space, then you have 1, 2, 3, 4, 5, 6, 7, 8, then you have another dot, 1, 2, 3, 4, 5, 6, 7, 8, you have another dot, then you have the last one, which is 1, 2, 3, 4, 5, 6, 7, 8. So each one of it is called an octet. So the dot is referred to as period in this instance. So even make it further easier, the binary is now converted to decimal, and you have so because of the above structure, it is called dotted decimal. To combine both of them together, binary is base 2, is a number system that only uses 2 digits, which is 0 and 1. And if you look at the dotted decimal, decimal is a base 10, is a standard number system. So it just uses 0, from 0, 1, 2, 3, and all that. So since we have 8 octets, which is eight of them, it starts from 0, 1, 2, 3 up to 7. And we know that binary, which is base 2, if we had them all together like that, then we now have, 2 2 raised to the power of 0, 2 raised to the power of 1, 2 raised to the power of 2. So if we do them like that, then we have, for the 8 zeros, then we now have 128. 2 raised to the power of 7 is 128, and 2 raised to the power of 6 is 64. So up to 2 raised to the power of 0, this is 1. So these will be like the first octet. Imagine if you now have like a dot here, and have the same thing for the complete set of these 8 octets, like in 4. So when you have something like that, then if you had all of these together, 128, if you had 128, 64, 32 up to this, what you'll be getting would be up to equals to 255. So all of this all together is 255. So if you had 128 to 64, that is 192. Add it like that to 32, you will get 224. Add it to 16, you get to 40. Add it to 8, you get to 48. Add it to 4, you get to 54. Add it to 2, you get 252 to 4. Then add it to 2, you get to 54. Then the number 1 makes it all 255. So basically, you just want to keep this in mind. This is how the addressing system is. IPv4 is in 4. It has 2-bit system. If you count all of these, this is 8, 8, 8, 8. So if you had all these together, it's 32. So that's why it's called 32-bit system. And then just know that all this is when it is all off, it's all zeros. When it is on, is 1. So basically, this is the structure of the IP addressing system. So if you have this in mind, and then you can, for example, if we then look at, let's just take an IP address system of 192.168. Let's take a class C, which we will talk about soon. And if you do something like this, basically what you are saying is that you have 1, you turn on 1, 3, 4, 5, 6. So this is 1. Let me get my pen. So basically, this is 1, 2, 3, 4, 5, 6. So we still have one more 0 that we still need to put there. You have to complete it in 8. So you have we have it's like 1, 2, 3, 4, 5, 6, 7, 8. So that is 192. So dots, then you have 0, 1, 1, 0, 1, 0, 0, 0 dots. All this will be 0, 0, 0, 0, 0, 0, 1, 1. I hope I'm right. 1, 2, 3, 4, 5, 6, 7, 8. Yes, 1, 1. Then the last one will be all 0. That's 1, 2, 3, 4, 5, 6, 7, 8. So I hope this makes sense. So basically, this is the way the IP addressing would be. So how did we get to here? If I said I have 192, 168, it just means that the first two are turned on, which is 128 plus 64. That makes 192. It depends on where you are looking it from. If it's from the left-hand side, it means that the first two bits are on. If you're looking at from it from the right-hand side, it means that the last two bits are on. So the same thing with this, you see for 168, we know that what do we have to make 168? If you use 128, if you turn 128 on, if you turn the second one on is 192, which is more than 168. So we put that off. If you had 32 to it, if we had 32 to it, it means that 128 plus 32. What do we have? We have 160. So what are we left to? You say that if we had 16 to it, it would be, if we had 16, what we have is 176, which is more than 168. So that means we are going to turn that off. We are going to turn that on. So what do we need? We only need 8 in this sense. So that's why this number 8 here is the 8 bit, the 1, 2, 3, 4, 5. So, for the sake of, consistency, let's be counting it from the left. So we will count this as 1, or let's count it from the right. So that makes sense since we are starting 0, 1, 2. So let's count from the right. So that means that the 1, 2, 3, 4, the fourth bit is turned on, which is the 8. So which makes sense. So if you now add all the horns together, that's 168. So that's what gives us this. But if we look at this, what makes 3? Then we start from here. The first two bits are then turned on, which is 1 and 2, which is 3. Then the last octet is all zeros. So this is how you would be converting this decimal. So, for easier read, that is why it's turned to decimal like this. And then because if we are to be doing everything in binary, as we see it here, it will be so difficult. So that's why it's called dotted decimal structure. So, but for breaking it down, we turn it back to binary so that we can understand how many bits are on and how many bits are off. I hope that makes sense. So this makes sense to be all zeros. So that is the structure of an IP addressing system for us. So we would be looking at this again in the subnetting structure to help us. So bear this in mind, the dotted decimal from binary to dotted decimal. Dotted decimal is mainly for easier read so that we can all have it like this. Binary is when you want to break it down and you want to know how many bits are on, how many bits are off in the IP addressing. So that is that for this. In the next video, we would look at the IPv4 address classes. Do you like what you've just watched and you'd like to learn more? If you are ready to master cloud networking and unlock the full potential of cloud networking for GCP with some insight into AWS, this is just the beginning. I've created a complete step-by-step course on Udemy that will guide you from a beginner to an expert. In the full course, you'll get hands-on projects, quizzes to test your knowledge, and continuous access to all the materials. Ready to take the next step? Click on the link in the description below to enroll in the full course on Udemy. I can't wait to see you there. Thank you.